ML.NET is a machine learning library for .NET developers. So if you are a C# developer who wants to start adding custom AI and machine learning to your applications, ML.NET is a great way to go. Now, there's many different ways to do AI. A lot of them are using languages like Python. A lot of AI is also currently done in just what's called notebooks. So basically a piece of text with code samples intermingled, and then you pull some data and you do some stuff. And one of the things that I notice in AI development today and data science and all that is you get a lot of people doing interesting stuff with data and AI, but it's always kind of a proof of concept type of thing. So when we do AI, it was always very important for us that not just could we do some stuff and demonstrate that we can do it, but to actually put that in production. And I think that's one of the bigger hurdles right now is for people that want to use AI, that they have a hard time putting it into production. And I find if you're a .NET developer, ML.NET is a great way to go. It offers all the same features that other languages provide, but it fits very neatly into .NET applications. You can use it to train AI either on your machine or on the server. You can use it to execute AI. It creates standard models. So typically when you do AI, you train models and then they get stored in a certain format. In particular, Onyx and TensorFlow are very, very popular formats that are created by many other languages as well. So ML.NET creates that too. And so it's interchangeable and just a very good way to go. So let me show you an example of what we're doing with this. And this is actually out of one of our production applications. When you go to our website, you will notice that, say, just on the homepage of our website, there's a form on many of the pages that allows you to contact us, whether that is because you have a software project you need help with, whether that is because you subscribe to Code Magazine and your issue didn't arrive, or many, many different things. So you put in your name, blah, 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 and put in some text. Ideally, you specify a topic that this is about, so it gets passed on to the right department internally quicker. And then you put in whatever text you want. And people do. So most people, seemingly, the text they want to put in is spam. Not surprising. So we were battling the spam problem for a long time, just like people are in email. But of course, this is also a kind of a more targeted scenario. So it's a lot easier for us to find out what's spam versus information that we actually want to take a look at, because we know kind of what it has to be about. If it's not about the magazine or software development, it's probably spam. So we decided to train an AI model using ML.NET. So what do you need to do when you use ML.NET? Well, the first thing you do is you need some training data. And this is where the stuff you do in the real world is quite different from what you read a lot about when you do first AI samples and stuff. So what we do is we don't have a CSV file with examples of what's spam and what not, but we have our general system that goes to backend data. A lot of it is in SQL Server and similar databases. And so the first thing we do is we have some data access infrastructure here that gets us training data for this particular purpose. And we could look into that, and in this case it just goes into SQL Server and queries data, and it basically says give me data that we know for sure is either spam or not spam, confirmed as such, and ignore some of the stuff we did internally for testing. So that's a very common thing you do when you do machine learning, is you have to get data and you have to massage it to be representative for machine learning. So we get that and we pull it out. We then massage it a little more. So we just look at certain data like, is this spam true or false? In our database, we have a status. We know, is it spam? Is it confirmed spam? Is it suspected spam? Do we not know? Is it suspected or confirmed not spam? Has it not at all been classified, and so on? What we want now is just a true false flag. Is this spam or not, for things we know? We also take pieces of data that we know or suspect is important to identify whether something is spam or not, like sender name, sender company, the subject text they post, and of course, most importantly, the actual message that they send us. Okay. And then we do some statistics, and that's not particularly important. But then what we do is we use this ML context object. So ML context is an object that ml.net provides to us. ml.net itself is just a NuGet package that you can add. So when we dig into the dependencies of this, you will see that in here is Microsoft ML that we just pulled in as a NuGet package. That's all you have to do. No need to have to create an Azure service or anything. This is just on your local machine in that case. So we pull that, and we then tell that context to load that data. So that's great. Then we say, when we use machine learning data for training purposes, we usually take a segment of that data, say 80% of that data as a random sample to do training. And then once we train the model, we take the other 20% of the data and say, okay, now let's try it out and let's see the model we have. How does it do if we actually ran it over those other 20% of the data? And we then say, is this spam, yes or no? And now let's compare it to what we know it to be, right? So we create a so-called test fraction, which ml.net provides us a way to split our data set randomly into training and test sets. And then we build up what's called the training pipeline. So I can use this ml.net context to perform a few transformations to make this suitable for training. So the first thing we have to do is we have to take the message, the actual message that people send us, and we can take just text. Machine learning operates on numbers. It's math, which means text is awkward to use. So we have to somehow turn a lengthy text message into a numeric mathematical representation of itself. This is a process known as featurizing, which is in itself not that trivial, but we can use this featurized text method in ml.net to featurize our message, and then give it, makes a new column in the database if you think like that in memory data, and give it a certain name. And what that does is it turns it into an array of vectors if you're interested in what's happening under the hood, and you can take a look at that. So we do the same thing with the other text fields that we want to consider. And how do you know which text fields to consider? There's tools that help you do that, but there's also just a lot of trial and error of trying to just do this and figuring out what works the best. Okay? And then finally we say, okay, use all these fields that we have now created and featurized, and those are what we call the features. The features are the things that are important for training. The features are the columns important for training if you want to think of it in a database type of scenario. Okay? And then we go ahead and we say, now let's go train this. And in this case, for demonstration or test purposes, this is actually production code. We have a set of different ways of training this. The most common for something like this is SDCA logistics regression. So ML.net provides a number of different trainers to train this machine learning model for future prediction. And in this case, what we're training for is binary classification. Binary classification means it's either a yes or no answer. Is this spam or not? There's many different things you could do. You could do categorization, you could do a probability predict, whatever. But in this case, we just want a yes or no. Do we think this is spam or not? That's called binary classification. And we just go ahead and say, train based on the is spam flag for a yes or no answer on all these features we define. And now this thing goes out and it runs its training. So we can actually kick off the training mechanism by calling the fit method. Fit is trying to fit the data, trying to train a model that fits these things in the training data to what we want the outcome to be. In this case, a flag that says is it spam or not. So it will learn on that data. And this may take a while. Now we have in our database tens of thousands of messages that are spam or not. And training that takes about less than a minute, 30 to 45 seconds, something like that. I think what it trains on my machine. So not hugely long. We're not talking about training ChatGPT here. We're talking about something that can be done repeatedly, relatively quickly. And this is something, in the real world, what we're looking at, this code here is actually a microservice that we run up on Azure. And we could kick that off every day at midnight to retrain our model for even a better match as we get more and more data. And by the way, if somebody is listening on this talk who has been posting spam messages on our website, thank you very much. We have oodles of training data, which we really appreciate, so our algorithm works amazingly well. So anyway, so we run this training, and then you can pull metrics out to see how it works, right? So we say, what are these different score elements? How accurate is this, right? The higher, the better. And so there's different things you can now figure out, like what's the positive prediction? In other words, it finds spam messages very accurately. What is the negative prediction? It finds non-spam messages very actively. How many non-spam messages does it classify as spam based on this current training mechanism that we chose? And so very interestingly, we can get back different types of data. And then, we can run this kind of in an experimental mode, but we can also go ahead and save this away. What we do is we then take this model and we push it into an Azure Blob Storage account where we can save away this model. The model basically becomes a zip file that has in its contents the executable model that we could then use. So if we have a flag here that says go ahead and save this, we just go ahead and we push that up into Azure, and it then from that point on gets used as our real model that triggers when somebody posts a spam message. So that's all you have to do. You don't have to be a mathematical genius. You don't have to know what the algorithms do. You play around with it. You see what's the best algorithm. ML.net actually provides tools where AI helps you find the best AI model, kind of a very meta sort of thing. But it's cool. It's very, very easy to use and very straightforward and works really, really well. So then what we can do is we can use this model to classify things. Where we have that method, navigating around in production code here. So here's the classify spam method. So we can provide it some data. So we can say, here is something somebody posted, it has a message and a subject. Tell me, is this spam or not? So what we do is, again, we spin up an ML context. We get the model from our Azure Blob Storage, which we then cache for performance reasons. And we then ask ML.net to give us a prediction engine so we can take this input that we basically got here as parameters of the method. So these are just types where you define the structure, but you say, give me a prediction engine based on this model. And then we can use the predict method to say, here's the subject, here's the message. Is this spam, yes or no? Okay? We can actually go ahead and run this here. So as I start this up, what we're going to get is, we're going to get a Swagger UI that allows me to run my model. There it goes. It'll take a little moment. First time it has to load the model from Azure. So I'm just running this locally here, but somewhere in here, I have a classify spam method, and we could now go and say, provide some input here, like get leads on your website. Use our amazing search engine optimization services to turn eyeballs into leads. Something like that, which would be a clear spam message. And so we could actually run this, and then it may or may not get it right. Right, so in this case it says, yep, this is clearly spam. Now, it wasn't very difficult in this particular example because it was very clearly nonsense. But you get the idea, right? This is now a model that's trained for that. If you said something like, where is my April issue of the magazine? Can you help me? Because I have not received a magazine yet, and we execute that against the same model and says, oh, this is not spam, this is actually a real message. And the results we're able to achieve with that, because it's such a narrow use case, I think over the last 6 months in running this model, I believe there was one instance where it actually misclassified a message. So the results are pretty darn amazing as to what you can do with this. And this is one simple example, right? We have other things like at this point, people picking the department that they want this to be sent to. Is it a magazine inquiry? Is it a consulting company-based inquiry or whatever? We are now not even looking at that anymore, but we are actually predicting based on the content of the message what department and what person should be handling this and responding to the inquiry, which is a let's see, I can show you where that is. Oops. Which we're doing here, and it's very similar, except this time when we train, it's a multi-classification training algorithm that then, rather than saying yes, no, it says it's likely this department, it's likely that department, right? So those are a few examples in ML.net that you can do. You can do predictions of inventory needs, you can number of visitors to your website, all these types of things that machine learning models are good at this point. And you can do both shallow and deep learning, so there's also some neural net type of stuff in there. I can only scratch the surface here, but this is a really good way to go if you are a .NET developer. And this drives a lot of things that Microsoft does for their pre-trained services as well. So this is not a rinky-dink little thing. This is a very massive effort for Microsoft. And the cool thing is it's just so easy to use. So I'm very excited. We do a lot of stuff with this on all kinds of levels. This was a pretty simple example. Again, I always tell people that watch these events, if you are now sitting there thinking, well, gee, I wonder how that would be applicable to my particular company, feel free to contact us. We're more than happy to help you out. Like I always say, we're not the kind of company that'll send you an invoice for a 5-minute answer or an interesting discussion about what could be done. So feel free to consider us a resource there. And I highly encourage that you should be looking into some of this, because apps that don't have this type of functionality are just really going to be at a disadvantage in the marketplace.